Video will start you off with word problems, solving word problems using systems of equations. And the basic problem type, I like to think of it as a quantity value problem. So one equation represents the quantity or how many you have, and then the next equation attaches value to what was just described. So in problem like number 12, we have 100 baseballs and bats. And then we're told the value of each. So I will just let X represent the baseball, Y is going to represent the bats. So my first equation would be my quantity equation. How many baseballs and bats do I have? So I'm going to set up X plus Y equaling 100. And then my next equation will attach value to each. So a baseball is worth $4.50, so 4.50X plus 20Y. And the total purchase was $822. Now I'm not going to solve the systems on this video because I'm confident that you all can do that. I just would like to talk through the setups and then you should be able to take it from here. Let's look at the next problem. So here I have 40 children attending a baseball game. So let's see how we're distinguishing two things from each other. So each child has received either a hot dog or a bag of popcorn. So I'll just let X be the hot dog and Y will be the popcorn. So I have 40 children, that's my quantity. So X plus Y equaling 40. And then I'm attaching value to that. So I've got 2.25, attaching that to the X, and then 1.75 will go along with the Y. And then the total amount of money spent, $83.50. Let me set up one more on the video. And let's see, now I'm at a theater, so 548 tickets were sold. So I have two types of tickets. I have adult tickets and I have child tickets. So I will let X be the adult, Y would be the child. So the number of tickets sold, my quantity is 548. And then how much money did I spend? The value attached to that. So I would have 6.5X. And then the child ticket was $3.50. And then the total amount of money spent, $2,881. So I think that most of the word problems and systems of equations are designed like this. One equation represents the quantity, the next equation represents the value. And they're all basically just a takeoff on that in this particular problem set anyway. So I'm going to move on now to another type of word problem. And I'm going to move to the cross number puzzle. And I would like to show you how to work through and think about this. The sum of two, let's just look at number 2. The sum of two numbers is 26. Their difference is 4. Find the smaller number. I would like for you to use systems of equations for this. So they've given us the first answer of 11. But the way they did that, I can now use two variables. So I could say the sum of two numbers, and I can let X and Y represent the two numbers. The sum is 26, and their difference is 4. So I can solve this simple little system in order to arrive at that answer. So the object is not to figure these out using brain teaser type techniques. The object is to figure these numbers out using systems of equations with two variables. So let's look at a few more to give you some confidence with this. Let's see if I can find, okay, number 12. Two angles are supplementary. That means that they would sum to 180 degrees. Two angles are supplementary. One of them is 3 times the other. So if I let X and Y represent my two angles, when I add the two angles together, that should equal 180. And then one of the angles, it doesn't describe which one, but it just says one is would be equated with the equal sign, 3 times the other. So here's my system for solving. And these are simple systems. Once you get the system set up, they're very, very easy to solve. So the challenge or the skill comes into setting the system up, not into solving the system. And let's look at one more on the video, and I feel like that should be sufficient for you all to get through this on your own. Okay, number 7, let's see, let's look at 16. Because in 16, they have the numbers and they're saying that one number is larger than the other and you need to take that into account during the setup process. So the difference between two numbers is 26. So I'm just going to say difference, that implies subtraction. And for the sake of assumption, I'm going to assume that x is the large number. In some of these, you do need to decide who's large and who's small during the setup process. Then it goes on to tell us that the larger is, so the larger is 30 less than twice the smaller. So here's twice the smaller, 30 less. And then that becomes your system for solving. I feel like that is enough information to get you through this problem set. And I guess if you have questions, then you can just ask, but I feel like that's enough to get you through